So S stands for substitution and N stands for nucleophilic. N stands for nucleophilic. And 1 and 2 stand for unimolecular and bimolecular. And what is the meaning of unimolecular? One molecule is involved in the transition state. One molecule is involved in the transition state. And bimolecular, two molecules are involved in the transition state of the reaction. Okay. Now, this you will understand when we discuss about the free energy diagram of the reaction. Okay, so we have taken some a couple of examples here. The couple of examples are alkyl halide reacting with potassium hydroxide, where potassium hydroxide will generate the nucleophile, and the nucleophile is OH minus here. So OH minus attacks RX and forms ROH. Now the same nucleophile you can generate from silver hydroxide. That is what we have written there. You can see that on the board. I hope you can see the board. RX plus silver hydroxide AgOH gives you ROH plus AgX. So this is a direct nucleophilic reaction, and the OH minus is the nucleophile, RX is the reagent, RX is a substrate, and the OH minus is replacing the X on the molecule. The OH minus is replacing the X from the molecule, and you form the alcohol. Okay, and now you can see here OH minus, you know, OH already we have studied about nucleophiles and strength of nucleophiles. So OH minus is a stronger nucleophile than X minus. OH minus is a stronger nucleophile than X minus, and that is the reason why we get ROH as the product. Okay, it is not possible to reverse this reaction under this condition because OH is a bad leaving group. OH is a bad leaving group, and X minus is a bad nucleophile, not a very strong nucleophile. Okay, so we will discuss. We will take up certain reactions and then see what products. And then later we'll come to the mechanism of these reactions. Okay, next one, RX plus CH3ONA gives you ROCH3 plus NaX plus NaX. Okay, then and this reaction is known as, and what is the product here? What is this product? What's the functional group of the product? This functional group is an ether. The compound is an ether. Okay, and this particular reaction is known as Williamson synthesis. Williamson synthesis of ethers. Williamson synthesis of ethers. You take a alkyl halide, react with an alkoxide. This is sodium methoxide. Sodium methoxide. It's a white powder. Hygroscopic, reacts very fast with water and forms sodium hydroxide. So you should do this reaction under anhydrous condition. There should not be any water in this reaction mixture. So that is what you have to take care. You can use Yeah, you as an example, you can write it as let me write it C2H5, C2H5 Br plus NaOCH3, NaOCH3 gives you CH3, C2H5 OCH3, ethyl methyl ether. Okay, ethyl methyl ether or methoxyethane. Methoxyethane. Ethyl, this is ethyl group. Ethyl, this is methyl group. Ethyl, methyl, and this is the ether group. Ether. But the IUPAC nomenclature is this way. This group is known as methoxy, and this is ethane. The parent molecule is ethane. So that is a naming of any ether. Okay, naming of any ether is like this. See, the IUPAC name of ethers is like this. You take the smallest chain attached to the oxygen. Here you have one carbon. Here you have two carbon. Okay, now you attach the smallest chain to the oxygen. So this particular group, don't attach like this. O should not be attached to the C2H5. It should be attached to the CH3. So OCH3 is known as methoxy. And now methoxy group is on the ethyl, on the ethane molecule. From ethane, you remove one hydrogen and put this methoxy. So that is this is another example of a substitution reaction. Okay, you can have other examples. I'll write one more here. C2H5 I plus NaOCH3. C2H5, same compound, C2H5O CH3. Okay, but there is another reaction in which you have, if you have an alkyl halide, if you take an alkyl halide and react with silver oxide, alkyl halide RX, okay, and react with silver oxide Ag2O. Ag2O is silver oxide. If you do this reaction, what will happen is it will form ROR plus 2AgX. So this is another reaction in which you can prepare ether. But compare these reactions. This will give a very good product. Okay, quite easy reaction. But unfortunately, silver compounds are very costly. Silver compounds are very costly. Right? Silver compounds are very costly. So nobody will prefer this reaction unless and until this is very costly material. Your R and R, this is your product has to be quite costly to use this particular method. Right? So then next we can replace R, X. X can be replaced by CN minus, potassium cyanide. You will get RCN. Any nucleophile you can replace. RCN plus potassium halide. Okay. How will you write an example for this? Maybe let me write like this. I got Cl, take potassium cyanide. Okay. isopropyl chloride. So you will get that silent. Remember, generally this is done in water, okay? Or it's containing slight amount of methanol. Very, very easy reaction and very facile reaction which is very widely used in industry. Now, again, but there is one difference here. Suppose instead of this reaction, I take silver cyanide. This is something very interesting. Don't forget this reaction. If you are taking silver cyanide, you get a different product. The product is this one. Look at this. The nitrogen is attached to the carbon. So this gets reversed. It is this N minus, this is the N, this lone pair is attacking this carbon and forms what is called isocyanide. This is isopropyl isocyanide. Isopropyl. Isocyanide. So that is the difference between this and what must be the reason for this. This Cn minus is called an ambident nucleophile. Cn minus is generally known as an ambident nucleophile because it can attack either from this side or from this side. Okay, so you can make the Cn attack either from the carbon or from the nitrogen, okay, depending on the reaction condition. If you are using potassium cyanide, you will get carbon attached to this carbon. If you are using silver cyanide, you will get nitrogen getting attached to this carbon. You get entirely different products. Okay. Now, suppose you are taking RX, take an alkyl halide and react with potassium nitrate, NO2, KNO2, potassium nitrite. You will get RNO2. Easy to write. Plus KX. Plus KX. Similarly, you can do the same reaction by taking silver nitrate in alcohol, AgNO3 and C2H5OH. C2H5OH is acting as a solvent. So you take any alkyl halide, C2H5Cl or C2H5I, I will take C2H5I, ethyl halide. Remember, this is a better substrate because I is a very good leaving group. So you will get C2H5 NO2 it's not silver nitrate, silver nitrite, IT NO2, C2H5 NO2 plus silver iodide. Okay, plus silver iodide. Now, if you are taking carboxylic acid and react with the silver salt of carboxylic acid, if you take a silver salt of carboxylic acid, RCOOAG, and then react with, this may be reacted with RX, alkyl halide. Just 1 second. Yeah. So if you are taking a silver salt of a carboxylic acid, RCOOAG, and react with Rx, an alkyl halide. Okay, you will get RCOOR plus KGX. So what you can do is, it is very easy to write these substitution reactions. In the sense, what you have to do is look at the cations. Look at the cations. Of reagent. See, for example, here, what is a cation is potassium. And now look at your substrate. It is X. X can be Br, Cl, or fluorine, or iodine. Okay, so you know there are certain these basic compounds: potassium chloride, potassium bromide, potassium iodide. These are basic compounds which we come across in our inorganic chemistry, and they are very stable compounds that can be easily formed. And see here, so you just make that compound. See here, you have the silver here, and you have X here. Okay, so you just remove them and prepare that. That can be easily done. Now what you have to do is just replace other one. R, so the product is RCOOR. For example, I take silver salt of acetic acid. I take the silver salt of acetic acid. What is the silver salt of acetic acid? CS3. Oh, what happened? My pen stop writing. Right. One second. My pen is giving a problem. Let me see whether I can do it with my hand without. Oh, my pen has stopped working. One sec. Stop. So CS3 work now. Try again. One second. I'm lucky it will work. Oh my god, it's not working.